We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 15, Exercise 15.3. Find the area of the minor segment of a circle of radius 14 cm when the angle of the corresponding sector is 60 degree. So here we can use the direct formula. So we have a circle here, then the radius is also given 14 cm and there is a minor segment. Now here angle is given 60 degree. So if you use the formula, then you have to find out, because you can just subtract it or you can use the direct formula. So what we will do here is, we have already known the formula. But what is the actual science or technology behind it? Let me see that I can tell you the logic here. So what we will do, this is 60 degree. So we have a triangle and this is 60 degree. So this side is radius and this side is radius. So this angle and this angle will be 60 degree. So this triangle is an equilateral triangle. So if this is 60, this is theta and this is theta, I'll just tell you how we make it. 60 plus theta is 180 degree, because the sum angle of a triangle is 180 degree. Now take this 60 here, so theta is 2 theta is 180 minus 60, that is 120. So theta is 60 degree. This is how we got the angle here, 60 and 60. So when we got the angle 60, it's an equilateral triangle. When we have an equilateral triangle, we can say that this area of triangle, that is area of triangle, will be equal to root 3 by 4 side square, that is root 3 by 4 14 square. This is area of triangle. Now let us find out the area of the sector. We know the area of the sector is what? It is area of sector. It is going to be theta by 360 into pi r square. Theta we know 60, so 60 by 360 into pi r square. So pi you can use as 22 by 7, r is 14 into 14. Now this total sector, if we subtract this triangle, then we get the area of minor segment. So you have to subtract root 3 by 4, just 14 square. And this is nothing but the formula we used earlier. If you remember, theta by 360 into pi r square minus sine theta by 2 cos theta by 2 r square. This we have already seen. So this is how the logic works here. So when you just try to solve this one, you will get this one as 308 by 3, and this of course will be root 3 by 2 root 3 by 4 14 square, that will be 49 root 3. So this is the answer. This is the way you have to approach this type of question. A chord of radius which is 20 centimeter. This is radius, a chord of radius. So there is a chord and there is a radius which is given as, this is 10. So 10 centimeter. So it subtend an angle of 90 degrees. So we have a circle and there is a chord and it subtend an angle of 90 degree. This is 90 degree. At the center, find the area of the corresponding major segment of the circle. So we have to find out the area of the major segment. The question here is somewhat different. We just don't have to find this area. Basically, we have to find out this area. I hope you got the idea. In this question, we have to find out this area. For that, what we will do? We will find out this minor segment area, or rather what we can do here is, we have a sector here with 90 degree. This sector is 90 degree. But what is this angle? 360 minus 90. So what is 360 minus 90? It is 270. So this is the angle 270 from here to here. So this is a sector again. It is also a sector with angle 270 degrees. So we can find out the area of this sector. Right? We have to find out the area of this sector. So for that, what we will do, we will use the formula directly. That is, now theta by 360 into pi r square is the area of this sector. But we are interested in finding the area of this sector. So we'll use 270 degree rather than 90 degrees. So 270 by 360 into pi into 10 square. This is going to come as 235.5. Now coming to this area of triangle, because area of triangle has to be known and we have to add the area of the triangle with this one. We need to add this. Then only we say this is the area of the bigger segment, major segment. I hope you got the idea. We have to add these two. So we have to find the area of this triangle also. So now coming back to the triangle. This is a triangle. Now the angle is, this is 90 degree. This is 90 degree. And the radius is given. So we have the radius as 10. This is also 10. So how to find out? Because in order to find the area of the triangle, we need half into base into altitude. Half into base into altitude. This is what the area will tell us. Okay. So half into base into altitude. See, this is 90 degree. This is 90 degree. So if I take this 90 degree, this will be 45 degree. This will be 45 degree. Why? Because these two sides are equal. These two sides are equal. So in order to get this side, or you can say half into base into altitude, this we already know. So there is another method which you see here, but I'll tell you a very short method. This is the base and this is the altitude. So half into base into altitude. We already have base and altitude. This is 10 and this is 10. So half into 10 into 10. Base into altitude. You don't have to go for this cos 45 or sin 45, etc. You already have, because this is 90 degree. For an angle, for a triangle with 90 degree angle, this is base and this is altitude. So just multiply this, half into 10 into 10, which is going to be 50. This is 50 centimeter square. So now we have this sector area. We have now this area also. Just add them so that you get whole of this area. So 235.5 added with 50 is going to give you 285.5. And this is your actual area. This is what is you are interested in. I hope you got the idea. This 50 we got from here. There is another method also. So there are two methods to find the area. But ultimately this area has to be added to this sector. The radius of a circle with center O is 5 centimeter. So this is 5 centimeter. This is 5 centimeter. Two radii, this is OA and OB. These are drawn at right angles to each other. So this is 90 degree. This is 90 degree. Find the areas of the segment made by the chord AB. So we just have to use the formula. And then first formula we'll try to find out for this one. This segment, and we know the formula. It is r square. I'll just write the values directly. R square is 5. So 5 into 5 r square. Then you have theta into pi by 360. Theta is 90 degree because it is given. Theta by 360 into pi. You already have this, so just make it 3.14 if you want. Then minus sine theta by 2 cos theta by 2. Theta is 90, so theta by 2 will be 45. So sine 45 cos 45. Sine 45 is 1 by root 2 and cos 45 is 1 by root 2. So what do you get? You get 25, and this comes to be 0.785. This is 1 by root 2 into 1 by root 2, that is 1 by 2. 1 by 2 is 0.5. So you have 0.5 here. So this becomes 25 into, this will be 0.285, and this gives you the area of the smaller or minor segment. It is called as, it will be 7.125 centimeter square. Now this is the minor one. In order to find the major one, just subtract this from the whole area of the circle. So area of the circle is pi r square 3.14 into 5 into 5, which is going to be 78.50. Now you just have to subtract these two. That is, you have to subtract this 7.125 from here. So 78.50 minus 7.125, and this is going to come as 71.375, and this is the area of the bigger one, that is major segment. Area will be always in squared unit. AB is the diameter of a circle. So this AB is the diameter of circle of center O. C is the point of the circumference. So C is here, point on the circumference, such that COB, that is this angle, is theta degree. The area of the minor segment cut off by AC. So the area of the minor segment, so this is AC. So area of this minor segment, that is this one, is equal to twice the area of the sector BOC. So this is the BOC, is twice. So what will be the area? We'll just equate them. There is nothing much we have to do here. So first of all, the area of the minor segment is what? See, first of all, this is theta. So what will be this angle? 180 minus theta. So this angle will be 180 minus theta. So in order to this AOC, this sector, in order to find out the area of this segment or this sector or this segment, sorry, minor segment, what we will do? We will use the formula directly. So this is r square theta by 360 into pi. What is theta? 180 minus pi. This is 180 minus pi. So 180 minus theta, this is theta, pi by 360, right? This into this minus sine theta by 2 cos theta by 2. So what is theta here? 180 minus theta. Sine 180 minus theta by 2 cos 180 minus theta by 2. And this is given as twice the area of sector BOC. It is equal to twice the area of sector BOC. But what is the area of sector? It is theta by 360 into pi r square. So this is theta only. This is theta only. So you can just write theta by 360 into pi r square. Right? R square you can cancel here. So we don't have to deal with this again. So what do you get here? See, 180 minus theta. First, I'll just tell you what we have to write here. Sine 180 minus theta by 2. This is sine 180 by 2 minus theta by 2. I can write it here. I can take 2 in the denominator for both of them. So it becomes sine 180 minus 2, 180 divided by 2 is 90. And this is theta by 2. So sine 90 minus theta is what? Cos theta. So this will be cos theta by 2. Similarly, with the same discussion, this will be sine theta by 2. So I'll write this as 180 minus this 180. I'll just change them. I'll just change them. So this will be 180 pi by 360, and I'll take them separately, and this will also I'll take it separately. So it is pi theta by 360, and this will be what? Minus sine theta by 2 cos theta by 2. This is equal to what? This is going to be equal to, this is 2 theta pi by 360. 2 theta pi by 360. Right? So what we require on the left hand side, this one. So I'm taking this here and bringing this on here so that I get sine theta by 2 cos theta by 2 on one side. So now sine theta by 2 cos theta by 2. What do we get here? See, this will be what? 180 by 360. So let it be like this only. Let it be like this. I'll do what? Sine theta by 2 cos theta by 2 equal by 2 cos theta by 2. I'll just write them all the way. 180 by 360 pi minus pi theta by 360. And I take this here and bring it here. So minus 2 theta pi by 360. Now I'm taking pi outside. Pi, because this pi is outside, see? So pi I can take outside. This is what? 180 by 360, this is going to be 1 by 3. So pi, and 180 by 360 is 1 by 2. Now what this will be? This is minus theta and this is minus 2 theta. So this will be minus 3 theta by 360. So this will be eventually 3 by 3 120s. This is minus theta by 120 degree. So this is sine theta by 2 cos theta by 2 equal to pi 1 by 2 minus theta by 120, and this is what was expected. This is what you have to prove. A chord of circle subtend an angle of theta at the center. So we have a chord and it is subtending an angle of theta. The area of the minor segment cut off by the chord is 1/8 of the area of the circle. So we have already the formula of this minor segment. What is the minor segment area? It is r square. This is r square. See, first of all, let me tell you what they have told. They have told that the minor segment area equal to 1/8 of the area of circle. Area of circle. So what is the area of circle? Area of circle is 8 times the minor segment area. What is the area of circle? It is pi r square. It is simple. Pi r square is the area of circle, and this is equal to 8 times the area of this minor segment, and we know the formula. It is r square and pi into theta by 360, pi into theta by 360, and minus sine theta by 2 cos theta by 2, sine theta by 2 cos theta by 2. This formula we know. Now the important thing is r square can be cancelled, and if you see this r square when we cancel, then what do we get? We need sine theta by 2 cos theta by 2 on one side, and it has 8 also. So I have to multiply 8 inside. So this will be pi and 8 pi theta by 360, and this 8 goes inside. 8 sine theta by 2 cos theta by 2. Now if you see this one we need on one side, So I'll take others on this side. So I'll just take this one here and pi here. So sine theta by 2 cos theta by 2 will be equal to what? See, I'm bringing pi here. So it will be 8 pi theta by 360 plus this. Okay, pi remains here. Pi is there. So I'm not bringing it here. Pi I'm not bringing it here. I'm just taking this on this side. So I have sine theta by 2 cos theta by 2 plus pi. So I have got the left hand side. See, 8 sine theta by 2 cos theta by 2 plus pi. So on the right hand side we have 8 pi theta by 60, and this is what? 360. What is this? 45 times, and this is pi theta by 45, and this is what was wanted. So we have sine theta by 2 cos theta by 2 plus pi. On left hand side, right hand side we have pi theta by 45. So this is what we have to prove, and this has been proved. So this is all about this exercise. Thank you so much and take care of yourself.